have to discuss about crystal growth and thin film. There are 4 different methods of crystal growth are available. The crystal growth methods are generally classified into 4 categories: growth from solid or gel, growth from melt, growth from vapor, growth from solution. First we have to discuss the solution and solubility. Solution is a homogeneous mixtures of solute in a solvent. Solute is a component which is present in a small quantity. For a given solute, there may be different solvents. A solvent of choice is one with good solubility for a given solute, good solubility gradient, less viscosity and less violence. The low temperature solution growth method from low temperature aqueous solution is extremely popular in the production of many technologically important crystal. The principal advantages of crystal growth from low temperature solution are the proximity to ambient temperature and consequently the degree of control which can be exercised over the growth condition. Through the technology of growth of crystal from the solution has been well preferred and involves works much patience. Power failure of a contaminant batch of raw material can destroy month of work. Materials have moderate to high solubility temperature range, ambient to 100 degrees Celsius at atmospheric pressure can be grown by solution growth method. This method is well suited to those materials which suffer from decomposition in the melt or in the solid or higher temperature and which undergo structural transformation while cooling from melting point, and as a matter of fact numerous organic materials which fall in this category can be crystallized using this technique. Next, methods of crystal growth. There are 2 different methods are available. The low temperature solutions can be subdivided into the following method. The first one is slow cooling method and second one slow evaporation method. In this slow cooling method, to grow bulk single crystal from solution, in this method super saturation is created by a change in temperature usually throughout the whole crystallizer. The crystallization process is carried out in such a way that the point on the temperature dependence, the concentrations moves into the metastable regions along the saturation curve in the directions of lower solubility. Since the volume of the crystallizer is finite and the amount of substance placed in is limited, the supersaturations require systematic cooling. It is achieved by using a temperature controlled water bath to control the temperature with plus or minus 0.01 degrees Celsius. The temperature at which such crystallizations can begin is usually within the range 45 to 75 degrees Celsius and the lower limit of cooling is the room temperature. The apparatus used for the growth of single crystals by this method. This is the schematic diagram for the slow evaporation method. In this method, the solutions loses particles which are weakly bounded to other components and therefore the volume of the solution decreases. An excess of a given solute is established by utilizing the difference between the rates of evaporation of a solvent and solute. Normally, the vapor pressure of the solvent above the solution is higher than the vapor pressure of a solute and therefore the solvent evaporates more rapidly and the solutions become supersaturated. It is sufficient to allow the vapor formed above the solution to escape freely into the atmosphere. This method of crystal growth is the oldest technique. It is very simple. For non-toxic solvent such as water, evaporation is permissible into the atmosphere, but for toxic and inflammable solvent, precautions are taken to avoid the leakages of solvent vapor in the atmosphere. The seed is at a lower temperature than the solution, rapid deposition of the solute will take place on the surface of the seed on its introduction in the solution. Thank you.